Hi everybody, Mr. Bowman here. In this video, we're focusing on all the excellence questions for the 2021 exam. Let's get straight into it with question number 45 from the website. So the equation, and we've been given it here, has two solutions. Those solutions being P and Q, and P is the biggest of them. We've been asked to find out, well, what's P minus Q? So first step here is we need to find these two solutions. Then we can figure out which one's P and Q. We can then get away or get around to subtracting them from each other. So we're going to start off with 6 is equal to 2x squared minus 11x. So I've got a quadratic, so I'm going to need to make it equal to 0 and then factorize to solve this. So I've got minus 6 to both sides, so 0 will be equal to 2x squared minus 11x minus 6. No common factors here, so I'm going to have to use the grouping method. And for this, I'm going to be going 2 times negative 6, and that gets me to negative 12. So I now need to find out, well, what adds to this negative 11 and multiplies to this negative 12? So I assume it's going to be something to do with 12 and 1. And because negative 11 is really big, it's probably going to be negative 12 and positive 1. So I'm now going to split up my negative 11x into a 12x, or negative 12x and positive 1x. So 0 is equal to 2x squared minus 12x plus 1x, or we're just going to write x in this case, and then that's going to become minus 6. So group number 1, I need to factorize that, and then I need to factorize group number 2. 0 will be equal to 2x, and then that's going to be x minus 2. Oh, that's some bad maths, isn't it? That should be x minus 6, right? Hopefully that's right. Yep, so 12 divided by 2, 6, perfect. No common factors here apart from 1, so we're going to be plus 1 and leaving me with the x minus 6. This is good. I was a bit worried I stuffed up there, but I do have the same bracket coming up twice. So I'm going to write that common bracket down. X minus 6 is over here. 2x plus 1. They're going to form the second bracket. So we've got 2x plus 1. I'm now solving, so x minus 6 is equal to 0. And then the second bracket, 2x plus 1 equals to 0 as well. So x1 over here is equal to 6. And then we've got minus 1, 2x equals minus 1. The second value of x is equal to negative 1/2. So because we've been told that p is going to be the biggest of these, that means P will be equal to 6 and Q will be equal to negative 1/2. So going back to P minus Q, we're going to have 6 minus negative 1/2, which is the same as 6 plus 1/2. So hopefully your answer matches mine. We've got 6 and 1/2. You could have written 6.5 as well. That would have been all good. We are now on to question number 46. And this here is actually maybe one of the hardest algebra questions that come up. It actually relies on a lot of year 12 questions. So we've been asked to solve this. So we're going to go w to the power of 4 minus 18w squared plus 81 equals to 0. So when I did this, I did something called solving with substitution. So what I'm going to do is I'm going to let x equal to w squared. So that means this here will become x squared, and this here will become x. So let's do that. So we've got x squared minus 18x plus 81 equals to 0. This here is quite an easy quadratic to solve. That's going to be x minus 9 squared. And based on that, that's equal to 0, we're going to have x minus 9 equals 0. So x is equal to 9. So now that I know x, I'm going to substitute it here. So that means 9 will be equal to w squared. So the square root of 9 is equal to w. So w is equal to plus or minus 9. So my first answer, oh gosh, plus or minus 9 is horrific maths, plus or minus 3. So w1 will be equal to positive 3, and then we got w2 being equal to negative 3. So yeah, this one here, as I said, a bit tricky unless you know how to do this solving by substitution method in the year 12 curriculum. So if you want to know more about it, maybe comment below and I can send you a link or something like that. We are now looking at question number 47, and we've got this messy equation here, and we've been asked to give an equation for x in terms of x or y and r. So just to clarify what that means, so that means x will be equal to some kind of messy algebra involving y's and r's. So that's our goal. So let's start by jotting down my equation. So r will be equal to 5y minus 4x over y minus 2x. So the reason this question is going to be really, really tricky, there's two x's there and they're on opposite sides of that fraction sign, and they're actually both locked away in brackets. So this is going to be quite annoying. So I'm going to have to move one over to the other side and then try to move it back afterwards. So I'm going to start, this here is currently division. Let's move it to the other side as multiplication. So that will end up as r with a bracket of whatever the denominator was. That there is equal to 5y minus 4x. This x is still locked away in a bracket, so it doesn't really help us yet. So we need to expand this. So that's going to be ry minus 2rx, and that there will be equal to 5y minus 4x. I'm going to move all the x's to this side and everything else to this side here. So what I'm going to do is I'm going to do plus 4x to both sides, and then I'm going to get rid of this ry, and I'm going to do that to both sides as well. So I'm going to have 4x minus 2rx, and that will be equal to, so that means those two have cancelled, and those two have cancelled. That will be 5y minus ry. So getting a bit messy. So I've still got two x's. They're not like terms because of that r, so I can't group them together. So my only choice is to factorize out that x. So x will be equal to 4 minus 2r, which is equal to 5y minus ry. I'm now going to move this over. Currently multiplication, it will become division when I move it to over there to the other side. So my final answer, x will be equal to 5y minus ry over 4 minus 2r. So a bit of a messy question, but we got there in the end. We are now on to question number 48. And this, in terms of my working, ended up being one of the longer questions that I looked at here. But yeah, let's see how it gets on. So we've got a perimeter of triangle A is 46, and we've been told the perimeter of rectangle B, I'm not sure why I'm saying triangle, 32. We've been asked to find the length and the width of both of these. So what I'm going to do is I'm going to form an equation regarding rectangle A. So let's do A, and that's going to be equal to 7p plus 7p. That relates to this side and this side. We're then going to have 3q and 3q for the rest of it. So plus 3q, and all of that comes to 46. So let's simplify that. 14p plus 6q equals 46. I now need to do the same for B, so rectangle B. So I've got 5p, 5p. So I've got 5p plus 5p, and that's 2q, 2q. So plus 2q plus 2q, and that there is equal to 32. And again, I need to simplify. So 10p plus 4q equals 32. Gosh, getting there. So I now need to, basically, because I've got simultaneous equations, two variables, I just need to eliminate them all from each other. And this one's going to be a bit messy. So what I'm looking to do here is equation number 1 over here, equation number 2 here. Q's, I can maybe deal with the Q's a bit more. If I get them both to 12Q, I can cancel them out. So what we're going to do is we're going to times this equation over here by 2 and this equation over here by 3. So my third equation, so that will be the third equation there. So we're timesing everything up here by 2. So that's going to be 24p plus 12q equals 92. And then along the bottom over here, that's going to be our equation number 4. Timesing everything by 3 this time, all of this by 3. So that's 30p plus 12q equals 96. So I've got the same amount of q's everywhere. So I can now go ahead and actually do that. So I'm going to go equation number, I'll do it the easier way, I suppose. Equation number 3 minus equation number 4. So this minus this is going to be negative 2p this minus this cancels each other out. And then this minus this, -4. So dividing both sides by -2. Oh gosh, I've forgotten the minus sign there. -2. Our p-value will be equal to 2. So we've got our first step of the thing. We now need to figure out what is q. And I'm going to go up to the top kind of one of these equations. I'm going to look at the easiest one, and I'm probably going to deal with the bottom one over here. So if p is equal to 2, that's going to be 10 times the 2 plus 4q equals 32. So that means it'll be 20 plus 4q equals 32, minusing 20 from both sides. So 4q is equal to 12, which means q is equal to 3. So I've got both of them here at this stage here. When I marked this one, because I was involved in the marking process, I think I was for this year, a lot of people left it here, and unfortunately that's just a merit. And that's because we haven't actually answered the question yet. We do need to figure out the length and the width of both sides. So rectangle A, don't forget, was 7p times 3q. So 7p is 14 meters. I think the units are meters, sorry, centimeters. And that was by 9 centimeters because it was 3q. And then rectangle B, this one here was 5p, running out of room here desperately, times 2q. That there was 10 centimeters by 6 centimeters. We are now on to question number 49. This one's going to be a bit messy. So we've got a rug and it says it's 3 by 2 meters. Lies in the center of the room, leaving an X border. So you'll see all these X's here. So that means it's X wide. And we've got the whole area of the room is double the area of the rug. So that'll be quite interesting. So the area of the rug is 6, which means the whole room will be 12. And that's meters squared. And we've been asked to find the area of the border. So this one here is actually going to be quite nice, I think, for us. So the area of a rectangle, or if you think of the whole room, would have been the height times the base, right? And we've actually already know, because we calculated it, because it's twice the amount, so we know that's going to be 12. The base of this shape is going to be this 3 plus the 2x's. So that there is going to be 2x plus 3. And the height is going to be the 2 that comes up and down here, and again adding the x's on top and bottom. So that will be 2x being the outside plus the 2 of the rug. So yet again, notice there's a common theme with the excellence questions. We've got another quadratic, and it looks like it's going to be the grouping method as well. So let's get in, let's expand this to start off with. So we're going to go this times this is 4x squared, this times this is 4x. And then along the bottom, we've got 6x over there, and then we've got plus 6. Simplifying this stuff in the middle, and at the same time, we'll actually move over this -12. So 0 is equal to 4x squared plus 10x. That's these two combined. And then we've got -6. So we're on the right track. I like this one here. There's a common factor. All of these are even numbers, so I can divide everything by 2, right? So 0 will be equal to 2. 2x squared plus 5x minus 3. So I'm liking this here, and then eventually I can actually just divide both sides by 2 to cancel that 2 out to make my life a bit easier. So 0 will be equal to 2x squared plus 5x minus 3. Unfortunately, no more common factors. I'm just going to have to use my grouping method. So 2 times -3 is equal to -6. So what multiplies to this -6 and adds to this 5? Hopefully you're thinking, oh, +6, -1. That one took me a while to get. Normally get them a bit quicker. So +6, -1. So 0 will be equal to 2x squared plus 6x. That comes from the 6 over here. Minus x, that comes from the -1. And just noting, 6x minus x is 5x, because that's the same as above. And then we've got -3. Grouping method here. Group number 1, they've got a 2x in common. So there's my 2x. And that leaves me with x plus 3. The second group, they've got a -1 in common, leaving me with x plus 3 as well. I haven't stuffed up because I've got the same bracket twice. my common bracket is x plus 3, and my leftovers are 2x minus 1, and that will be my second bracket. Okay, so we've got that. We now need to solve for my two steps. So we'll do them up here. So x plus 3 is equal to 0. So my first answer is going to be negative 3. And I'm already thinking x has to be a positive number. So this answer here, I already know that I have to ignore it. So x has to be greater than 0. So I'm going to ignore this particular answer. And my second one, hopefully I get a positive number. Adding 1 to both sides. So 2x plus 1. Oh, good. That's a positive 1. So that's perfect. Dividing by 2, x is equal to 1/2. So my answer, x is equal to 1/2. And that will make sure the whole room is double that rug. We are now on to question number 50. Looks like 56, but definitely 50. And a nice mathier question. Solve this. My favorite type of questions personally. X minus 3 over there. And we're going to go minus all of that. X plus 1. And that there is equal to 3 over x plus 5. So just looking at it, I already know this is going to end up as a quadratic, because when you're subtracting fractions, the bottom two parts need to be multiplied together. That's going to get me an x squared. So let's start doing that. So the bottom parts are going to be x minus 3 and then x plus 1. My diagonals, that's going to be 2x plus 1. And my other diagonal, negative 2x minus 3. And that there is equal to 3 over x plus 5. So let's simplify the numerator of the left-hand side, this messy stuff, expanding all those brackets. We've got 2x plus 2. And don't forget, this is minus 2 times x. That's going to be negative 2x. And then minus 2 times negative 3, positive 6. All of that is over my brackets. X minus 3, x plus 1, which is equal to 3 over 5 plus x. Okay, so we're annoyingly not there yet, because we've got to simplify the top of this. So, well, this 2x is going to be cancelled out by this minus 2x. So that makes my life a bit easier. So the top of that is going to be 8. So it's going to be 8 times the opposite of this, x plus 5, because I'm basically going to go this one times this one, and then this one times this one. So we've got minus 3 plus x. There we go. It's getting a bit messy. So this side here will be a bit easier to expand. That's going to be 8x, and then this one here is going to be 40. This one here, I'll maybe leave the 3 out front and expand this. So that's going to be x squared. We're going to have positive x, and then minus 3x. That's going to be minus 2x, and then we've got minus 3. Expanding that, that's going to be 3x squared minus 6x minus 9. And that becomes 8x, or that's unchanged rather. We're now going to take away both of these. And then we're going to go minus 40 as well. And this will get me to my endish quadratic. So 0 is equal to 3x squared minus 14x minus 49. So at this stage here, we're going to use the grouping method. Again, it's going to be a bit messy here, I think. So we've got 3 times negative 49. Negative 49. Annoyingly, that's going to be negative 147. So I now need to think what adds to negative 14 and multiplies to 147. And at this stage here, I am a bit like, I don't really know what's happening. What helped me do this one when I practiced it was the 14 and the 147. Both of those are to do with the 7 times tables. So I started thinking about the 7 times tables. So 147 is actually 21 times 7. So we've got some 7s. And if that was negative 21, that would then get me to that negative 14 I'm looking for. So those were my two answers. A bit tricky getting there, to be honest. And I'm desperately running out of room here, so I'm going to skip all my working. So there should be some working. And my final factorizing, once I finish the grouping method. If you want help with the factorizing part of it, comment below and I'll maybe reply with all the working. So we've got x minus 7 was one of the brackets. and the leftovers was 3x plus 7. So I've got my factors. I now need to split those into the two equations, and we're going to look to solve. So we're just going to scoot on in this direction here. My first answer, x minus 7 is equal to 0, so x1 will be equal to positive 7. And my second answer, 3x plus 7 is equal to 0. I'm going to go minus 7 minus 7. 3x equals negative 7. So the second answer of x is equal to negative 7 over 3. There's no real context here, so I can't really eliminate either of these as a false answer. So just going to leave it as they are. The final question from this video, question number 51. Ben is painting some straight lines on a field for a rugby team. The total length of all the lines is 20 meters, and the shaded area was 14. So let's start off with the painted lines. So we had x, x, and then x, and then we had y and y. So the 3 x's and the 2 y's, they will combine to get to that 20. So the lines, so that will be 3x plus 2y, and that there comes to 20. The area, this one's a bit easier. So we'll go with area xy equals 14. So that's a bit nice and simple there. Now from here, it's not particularly obvious how to solve this at this stage here. And I think there's a few different methods. The method I adopted was I actually ended up rearranging this first equation. So I did 2y is equal to 20 minus 3x. So that's me moving this 3x over to the opposite side, making it negative. And because I had 2y as the subject, what I did here was I doubled everything here. So if I multiply this all by 2, that gets me 2xy is equal to 28. And the reason I wanted to do that, because 2xy is the same as x times 2y, which will be equal to 28. And I liked this because 2y and 2y, I can take out the 2y and put in my 20 minus 3x. And that's what I did afterwards. So that's kind of the end of my working and my substitution. So 2y going away, 20 minus 3x going into its place. And then yet again, more quadratics. And again, you'll be surprised the grouping method is going to be involved. But let's expand this. So we've got 20x minus 3x squared equals 28. I'm going to move both of these to the other side. So that becomes negative 20x, positive 3x squared. So 0 is equal to positive 3x squared minus 20x plus 28. So got that. We now need to think how's the grouping method going to work here. So 3 times positive 28. So 3 times 28. That came to 84, is it? Hopefully it's 84. Yeah, 84. And I now need to think what multiplies to this positive 84, adds to this negative 20. And this here was an absolute headache to figure out. The strategy I adopted, I just went through all the factors. So I did the obvious one, 1 times 84. And then I've got 2 times 42. And then I've got 3 times 28. And I'm going to keep going. But what I'm looking for is I'm looking for one of the pairs to have a difference of 20. So we've got 4 and 21. Still not there. And then we've got 6 and 14. And I'm liking this last one here because while it doesn't have the difference of negative 20, they actually add to negative 20. So I could have negative 6 and negative 14. 2 negatives will multiply to this positive, and 2 negatives will add to this negative 20. So I got it. My last one over there. So 0 is equal to 3x squared minus 6x minus 14x plus 28. My factors, so that's going to be 3x, and that will be 2x minus x minus 2. No wonder I was confused then. X minus 2. And then the common factors over here is 14. So that's going to be minus 14, x minus 2. Perfect. Same bracket. So my factorized version, x minus 2 is the common bracket. And the 3x minus 14 is the second bracket, or the leftovers. So I've got my two factors. I'm now going to split them off and I'm going to solve them separately. So equation number 1, x minus 2 is equal to 0. So x1 is equal to 2. So I like that number. It's positive. So that's pretty good. And then my second one here, 3x minus 14 equals 0. So 3x is equal to 14. So x is equal to 14 over 3. Also positive. So I actually like both answers here. So possible values, I've got them both here. And that there wraps up this video. Hopefully you found it really useful. We looked at all the excellence questions for the 2021 exam.